How's everybody doing? My name is Frank Indiviglio. I work for HIPT at GFDL. I'm going to give you the scientific user's perspective on Lustre. And if we needed to sum it up in one slide, this slide would be it. The scientific user's perspective is this end product here. This is one of the high-resolution models that we were able to grow while running on Gaia that Doug was describing at Oak Ridge, supported by a Lustre file system. This is a sea surface temperature model of Western North America, and it actually really defines the Gulf Stream and Pacific equatorial currents. Not that I can describe why that's important, but they can. But you can see the detail in the model, and we'll see other examples later in the talk where this is a big deal for the scientists, and they're happy to see this. And just to give you kind of a 10,000-foot overview of how these models work, at GFDL we do more of an Earth system model. So we take the entire globe, cut it up into cubes, make it a distributed application. The grid only shows the atmosphere here, a vertical grid from height, the atmosphere height down to the ocean pressure in the ocean. So the grid actually continues down into the bottom of the ocean. It covers the land and the atmosphere. And you can see on the inset here all the not little things, but thank you. All the things that make up, that go into a climate model, from driving your car to volcanoes to clouds and weather systems. So what exactly is the user community at GFDL? GFDL, we have a variety of user experience levels with Lustre. We have some users that have used large installations for a number of years, mostly through Insight grants, predominantly on Jaguar PF, and others have been recently introduced to Lustre on Gaia within the last couple of months. We're really ramping up users now. So now we have most of our production users back running on Gaia, and this is their first couple of months running there. So we have a kind of interesting perspective, people transitioning to Lustre. So all the information that follows here is from the user base. I tried to interview users from each level of experience within the GFDL community, and they were very happy to give me all their opinions. So first, all the good things, right? So what do the users think? The users really have a good perception of Lustre. They're generally happy with it. It gives them the platform that they need to do large-scale experimentation. That's why that first slide is so important. That's the kind of model that defines policy, that gets into IPCC reports, and that's what they're there for. They're there to make their science better, to further the goals of NOAA, and that's the platform that they get to do it on, and it really benefits them. It also provides the size. We can scale this. One of the big factors of science, the scientists want to scale their codes up. They want to get better resolution in their models, and this is a platform that allows them to do it. So of all the users I talked to, all of them, they all agreed on these 3 points. The performance was great. They love the performance. A new user who I guess ran their first model within the last 2 weeks, their model initialization, just the startup, took 15 minutes. Now it takes 8. They didn't do anything. I mean, that's, for an entry user, that's pretty good. For a user that's been running for a while, that 15 minutes is down to, 5, which is a pretty good performance level, and that performance increase carries out to the rest of the model, not just the input. Reliability, they generally agree it's reliable and very stable. They're happy with the stability they're getting. Size, again, they're really big on scalability. They want big file systems so they can do big experiments. And less data movement. To give you an example, Doug mentioned workflow in his last talk, but for this, on the size here, in an earlier experiment at GFDL, each step of the model. So input needed staging to get data in. You ran your code. You had to output the data again to get post-processing started. Now we actually do that in one directory within the model. We don't have to move data around, so it cuts down time and processing as well. As far as the transition, education was really important. A lot of GFDL users have a very, very well established methodology in their work streams that depend on standard Unix tools. They all share a fairly common infrastructure, and it took a lot of, not a lot of work, but a lot of education to get, find the right replacement tools so they're not slowing down their work inadvertently. And the other thing the other education point that was, we had to cover very well with cover extensively with the users, that the file system isn't monolithic. There's no off switch, right? It can be, parts of it can be offline, parts of it can be running, but your jobs generally will still keep running unless they're dependent on offline files. So when we first ran into something, in a situation like that, I had, users kind of just went, well, the system's down, we're going to go off and do other things, and we had to explain to them that it's not monolithic. Your jobs usually start running, and no, your files aren't corrupt, they'll be back in a little bit. But that was one of the larger education points for us. And this is, okay, this is actually running, good. So this is just a visual representation of the forward progress we've been able to make on platforms, on Gaia specifically, but on platforms in general that is supported by Lustre. On the left is the couple model, version 2.1, which was used in the last IPCC round. It has a 200-kilometer atmosphere and a 100-kilometer ocean. And you can see, I mean, I don't have to really describe the difference. You can see the eddies forming here on the right side of the newer version of CM2.6. The CM2.6 was run on Gaia, and the CM2.1 was run on an earlier platform. But you notice the difference even in the land. The land is more well formed. It's not blocky. The left looks more like 8-bit graphics, and the right actually looks like a weather system or an ocean current system here. And not only did it need more processor power, but it needed a file system to back it up. And this is one of the better examples of how that was they were able to speed up their science, get better results by using a platform like that, and why they're very happy with it. Okay. So of course, users like to offer their advice on what needs improvement. So while they were very consistent on what they liked, their improvement was a little bit more varied. What they saw as improvement was a little more varied, and they actually, we'll go through a couple other points. But first, I wanted to point this out. This is a clip provided by Rich from Inside HPC. Thank you. This was the last question. I was at a conference in Newport, Rhode Island, the HPCC conference, 2 or 3 weeks ago. This is the last question of the conference. There's 5 people in the clip here. This is Addison Snell from Intersect 360. There are 2, I guess, user representatives, Don Lamb from University of Chicago, John West from the DoD Modernization Program, and 2 vendor representatives, England Go from SGI, and Stephen Wheat from Intel. And they basically are being asked to rate, I guess, if Lustre and PNFS were stocks, what would you be doing the next year? So let's see what they had to say.
Final question around the table, and this is more of a 5-second answer. Imagine, if you will, that PNFS and Lustre are stocks right now. They both got big years ahead of them, but PNFS and Lustre are stocks. Are you buying or selling right now? Don?
I'm holding with PNFS. I'm selling Lustre.
Hold PNFS, sell Lustre. John?
I'm selling. I think the long-term outlook is dim.
Eng Lim?
Hold both.
Hold both. Steve?
Buy both.
Buy both.
We absolutely have to have the solution space, and it's too early to decide which way it's going to go.
I'm buying PNFS. I'm holding Lustre.
Okay. So So I just wanted to show this, not to, you know, be not positive, but this was, I was sitting next to a user when this clip, you know, when this went on, and we have a 4-hour drive back to Princeton, and I heard about this clip, 45-second clip for 4 hours. If we think it's so great, why does it, you know, why isn't that perception out there? So I just wanted to bring it to your attention. I think it's a kind of a neat way to look at it, but there is a perception out there. Maybe that it's just misinformation, or I don't know what would kind of perpetrate that sell-off and hold there. But just an outside perspective, besides our users, and I wanted you to put through the same discussion that I had to endure in a car for 4 hours. So the things that need improvement from a user perspective, users think or feel that they're not insulated from bad practices of misbehaving users. So while that's true probably on every file system, they're more inclined to believe that on Lustre from either previous experience or just general, you know, the file system slows down and they think, oh, well, somebody's doing something bad and it must be that person's fault. They also they believe they don't have the necessary tools to manage the file systems and other user behavior. One of the things that kept coming up is this quotas aren't mature, they don't work. The way GFDL specifics, I'll say specifically, the scientists monitor themselves is through allocations, and the allocations go from compute time all the way down to disk usage. I have users that keep spreadsheets and check every day, and this is a big deal for them. And they're finding they have to actually go and look at how much they're using and kind of keep track of it themselves, and they view it as an issue. And slowness and viewed potential issues when using standard Unix commands and things like du. Part of, you know, people complaining about quotas is they go and use du and to see how much they're using, and that's probably not the right way to do it, and they're waiting for an hour to get the du information back. But, you know, it stretches out to other commands. Find, they should use LFS find instead of find, and I think that's part of the education process as well, but that's another one of their concerns. This one's actually a fairly large concern for them, and one that was voiced over the last couple weeks pretty loudly at me. When we moved from Lustre versions recently, users started to see holes in their data. What do I mean by holes? A model will run X number of time steps, we'll say 12. After the model completes, it does a little combined job to squish the output down into something that the post-processing will recognize. And that combined process usually is where it happens. After the combines run, it runs tar. The tar will error something, oh, your file changed while I was reading it. And at the end of the tar process, they get 11 time steps. And they have to rerun their job and verify the results again. So this is kind of a big sticking point for them. It doesn't happen all the time. It's very intermittent. But the issue, you know, so we can maybe develop around it, but if we change the model code, it changes for a long time. These models get run and rerun and rerun, and 10 years from now they'll get rerun to do re-verifications and reassessments. So the users are really reluctant to change things like this because they're going to live with them forever, and they don't want to change it for what's perceived as a transient issue. And like I said, it surfaces intermittently, so it does become difficult for them and us to plan for all end cases. Back more, I guess, to the education point I was making before. A lot of them were confused with problems in their jobs resulting from file system failures or offlinings. They get an I/O error. They didn't know what it means. They've been kind of educated to be, okay, well, if there's a hole in your file, it's bad, you should rewrite it, regenerate your job. So there's been a lot of education in that field. Users weren't really sure if the I/O error they received in their output is permanent or transient. Was it offline? Was it not? How do I look for it? Again, that was an education point, but even after they were educated, they were more inclined to have, well, we need better messaging. We need something that tells us a little more information. Both from the user side and the management side, the parts of this file system are offline. Users and management want to be able to quickly adjust for this and stop jobs that were going to get affected. Hold all the jobs that we're going to read from that region that's offline, and ideally, obviously, this would be automated. So what they actually asked for was enhancements to either signal jobs or a scheduler or a command line tool or something that they could put in their job script when there were file system problems so that they can actually react to them. Like I mentioned before, they wanted better error messaging and reporting. So instead of getting IO error, file offline. I mean, they're not asking, they weren't asking for, a page documentation. They were just asking for something that's almost, something that's unique to that particular error condition. But they all did like the fact, even though, all right, let me rephrase that. They all liked the fact that the system was resilient to hardware issues as long as their jobs weren't killed. So they did like the fact the machine kept running, but they just wanted a little bit more information about things that failed. And the last thing here I have is both users and the management at GFDL view growing a file system as a painful process. If we add hardware to something, requires taking a long outage or rebuilding a file system. They both said that this would be easy. This would ease if we were able to grow a file system as they had in the past. It would ease scientific growth and allow a little bit more flexibility in future planning. And this is just something that they've done over the past architectures where they'd have a file system, buy more hardware, grow the file system, and move on. And they don't view that as them being able to do that currently. Okay, so in short, users have a really good perception of Lustre. They like the performance, they like the reliability, they like the way it scales. They're really happy with the way their science is running on it. Most points of the file system are reviewed favorably, and especially in their opinions, the most important points. Again, scalability, performance, size, all good things. Educating the more traditional user was really important in migrating them. A lot of scripting, training, and a lot of just redoing your scripts, restructuring things. That was really important, moving them on to Lustre. And the user perspective can be improved through little things, better reporting, better error messaging, and that would make good to great, right? And allow for the use of standard Unix tools. Like they didn't like the idea of having to switch between file system specific tools and Lustre and tools that they're used to using everywhere else. And the options for growth are important for planning and flexibility in the future. And this is going to be a very slow-moving animation. This is another model that was run on Gaia. This is a wave height and mean wavelength for the entire globe. It usually runs better than this, but it's a really big file, so I apologize for it running slowly. But this is just another example of things that we're able to do with platforms with Lustre. So with that, I'll open it up for questions. Is there anything I can answer? I'd be happy to. There's one, two. Man.
Questions?
Sure.
Oh, there we go. I don't know if you're aware, you can enable quotas in a monitoring mode, so that you don't have to run like DU, so users can have without enforcement, right?
Okay.
So that they'll avoid the lengthy DU. I agree that DU is slow. The other thing I was a little bit puzzled about was the file system growth issue. It's possible to add OSTs online while the file system is even in use, and so it shouldn't have to take a big outage like that to increase the file system size. But
Like, yeah, that was, that they proceeded. I don't know where that comes. The growth thing, I know you can add OSTs. I don't know where that. One more.
I was kind of curious what efforts you've done. I know you mentioned that one of the things users complain about is perception. They're not insulated from other bad users doing bad I/O, which is something I see quite a bit. We get complaints. Oh, Luster's slow, and it's like, no, it's just being hammered by someone else doing something really bad to it. Do you work to identify particular users that are doing bad things and help them remedy it, or what sorts of actions are you taking to help correct that perception?
I mean, we'll work with the user to improve whatever it is that needs to get improved. But we have there's an application staff that'll, along with the system staff at GFDL, and we'll also ask for help from the Oak Ridge staff to better educate and then align that application to the system. So we're willing to go and basically fix what the problem is. Usually, for the most part, the models share a framework in terms of I/O, so that's not usually the model code itself that's doing unfavorable things. It's usually the scripts that the users put together for themselves, and that's a little easier to fix, right? So that's more of Doug kind of alluded to it in his talk, where it's not just a model run. There's a lot of data combines and data movement that goes on, and that's usually where the issues are. And those are a little easier to fix. If they're application issues, we'll go and fix those as well.
So, Guy Coates, Sanger Institute. So, I just had a comment about OST edition. So, yes, you can do online OST edition. The problem that we found is, of course, you end up with a very unbalanced set of OSTs on a file system that has very low file turnover. So, it's not a scratch file system, it's more persistent. We then have to put a lot of effort into shuffling files around to bring stuff back into balance again. It solves half the problem. Yeah, basically we have to go and start looking for big files and start moving them around again.